system. A lot of systems where we're putting this in, there's no power on the site, obviously, and with one of these, your battery bank and your renewable energy, or some solar panels or a wind turbine, we can just have the three devices together, and we can plug our saws, our drills and stuff into here and run those to build the house. So you can create the house around the system, and then you can then move them into a more permanent location once you're finished. So once we've got them in a permanent situation like we have here, we then have in the back of the unit a junction box, and we run a wire from there that goes up into the fuse board inside the house.
Why is it that you decided not to use these gas fridge freezer systems?
There was a number of reasons. The primary one is that if you're in a very remote location, you can't necessarily always just jump down the road to get more gas. And with it being gas, means that it's something that I have to still pay for and get it in, and it until I have something like a methane digester or we can perfect hydrogen gas to use, then it's still an expense that has to be calculated in. The other reason was mainly because they've still got to develop this market. It's still quite a limited market using gas appliances, and so the efficiency of them is not really high enough. Like with this freezer unit, they've managed to thicken the walls of it, but the door's still pretty limited in what it can, in its insulation ability. And the other thing with it is that the gas flame on it is burning all the time at a continuous roar. And so I was going through quite a lot of dollars worth of gas. However, with this fridge freezer unit that we've got here, it was very, very, very good. And with having the ice box above it, and then having the large area in here, but also you could, with the flick down here, you could adjust what you needed to set the temperature at, and it used very, very little gas. It's only like a batch. That's very useful. So you're not using it all the time, and it has a place for that.
Simon, I see that you've changed your inverter from before. What's the difference between this one and your old one?
Yeah, it's a good question, Christina. The difference between this one is that it's a bigger capacity. This is 1 kilowatt bigger in size, so this is actually a total of 3 kilowatts continuous. This means that in the house we can have the microwave going at the same time as the washing machine, and maybe even the same time as the vacuum cleaner. We don't have to look at what loads we have on at different times. So the house is very much like a normal house where you just keep turning on appliances in the house and the system can cope with it. One of the other differences with this inverter is that it allows for us, when the power board will allow us, instead of having a battery bank behind me, to push the energy back into the national grid and use that as the battery bank, then this inverter will synchronize with the national grid and push it in. And so it has the capability already built into it for that. The other advantage of it is that it allows you to plug a fossil fuel generator into it and act as a big battery charger, and you have an emergency situation where you need something like that in the middle of winter.
So I see that you've got a lot more batteries than you had before. Why is that?
Yeah, well, last time we had individual 6-volt cells. Now we have each one of these is 2 volts, and we add them up to give us 24 volts across here. So it's still the same voltage, just need more of them to do that same. But what we've got is more storage. This means that instead of only having about a week storage, we now have between 2.5, even maybe even 3 weeks worth of storage in these batteries now. This allows us to get through the horrible winter periods that we have here with no problem with worrying about the batteries at all, and with no problem of having to think about turning on a generator or anything like that.
Yeah. And I see that you've got some different solar panels here than the ones that you've got up on your roof.
Yes, what we've got here is emerging technology that's coming out on the market. What all the photovoltaic manufacturers are finding is that it's costing too much to manufacture traditional panels, and so they're looking at different and new technologies. This is what's called thin film, and what we've got here is a stainless steel back, and this is sprayed on here with a Teflon coating on the top, so we don't need glass, which reduces the cost significantly. And one of the real advantages of this is that it's about a fifth cheaper to manufacture, and therefore the cost coming out to the end user is a lot cheaper, and it's not affected by temperature in any way, which a lot of the existing technologies is. Without the frame on it, also the other advantages of it is that it becomes flexible. So what we're finding with this is people use this on marine applications, camping and things like that as well, because it is completely flexible. And of course with it like this, with no glass on it, people like Canon and other people that are making this, they're now making this into roof tiles. And so you put that directly on the roof rather than what I've got there. You've got existing roof, then you build a frame on it and put the solar modules on top of it. Here, this would just go straight on the battens of the roof, and this becomes both a roof and a generating system.
That's great, Simon. Thanks a lot.